Welcome back to another chemistry video. Today we're going to be talking about pH. So what is pH? Well, basically it's a measurement of how acidic or basic a substance is. To measure this, we use a scale of 1 to 14. Anything less than 7 is going to be acidic, while anything above 7 is going to be basic. At 7, it's neutral. First, let's talk about acids. The easiest way to describe an acid is any molecule that wants to donate a proton. A base, on the other hand, is anything that wants to accept a proton that an acid gives off. To illustrate this, here's a simulation of the reaction between hydrochloric acid and sodium hydroxide. Now, hydrochloric acid is an acid, and sodium hydroxide is a base. So what's going to happen is the hydrogen is going to dissociate from the chlorine atom, and it's going to bond with a hydroxide group in sodium hydroxide, and this will form water. Then, since chlorine is negatively charged and sodium is positively charged, they're going to bond together and form sodium chloride, also known as table salt. This mixture has now been neutralized, which means that the pH has been balanced out, since water and salt are both neutral. Now it's important to know the difference between strong acids and bases and weak acids and bases. To understand this, we first need to know something about water. It will naturally react with itself to form hydronium ions and hydroxide ions, which are positive and negative respectively. This forms an equilibrium reaction where water turns into hydronium and hydroxide, and hydronium and hydroxide turn into water. Let's take a strong acid like sulfuric acid. When mixed with water, it will dissociate completely. This means it will react with as many hydroxide ions as it can, which means that there is a higher concentration of hydronium ions than there is of hydroxide ions. Formic acid, on the other hand, is a weak acid. This means that it will only partially dissociate in water, meaning that only some of the formic acid molecules will react with hydroxide. So the hydronium ion concentration will be higher, but the concentration of hydroxide ions is still higher than it would be if the acid was strong. Now let's take a strong base like sodium hydroxide, like we talked about earlier. It also dissociates completely in water, meaning that it will react with as many hydronium ions as it can to form water. This leaves a solution with a higher concentration of hydroxide ions. Weak bases like ammonia will only react with some of the hydronium ions, meaning that there is a higher concentration of hydroxide, but there's still a decent amount of hydronium ions left. We determine pH by measuring the concentration of hydronium ions in a solution. These equations can be used to find either the pH or the concentration of hydronium. For example, if the pH is 6, we have a concentration of 1 times 10 to the negative 6 moles per liter of hydronium. At a much lower pH of 1, the concentration is 1 times 10 to the negative 1 moles per liter of hydronium, which is much higher. Finally, let's talk about superacids and superbases. These compounds are so reactive, they will actually react with the water itself rather than the ions generated from water. Because of this, the pH scale is not a great way to measure their strength. So as you can imagine, these compounds are extremely dangerous and must be handled with extreme care. To qualify as a superacid, an acid must be stronger than 100% sulfuric acid, which is already extremely powerful. So let's talk about fluoroantimonic acid. This unbelievably strong acid is 10 quadrillion times stronger than sulfuric acid, and will dissolve basically anything: glass, wood, steel, you name it. It's basically at the top of your list of things you do not want on your skin. Then we have superbases such as this one, called orthodiethylbenzene dianion, and the name is the least intimidating part about it. This monstrosity is so powerful that it can rip the hydrogens off of hydrocarbons. And keep in mind that these carbon to hydrogen bonds are very powerful. In a nutshell, don't play with these chemicals. Again, thank you so much for watching. Make sure to subscribe, and I'll see you next time.